In this video, we're going to talk about oblique triangles and the law of sines. So in this chapter, we're going to be talking about how to solve for various pieces of a triangle. So its angles and the length of its sides. And to do that, we're going to use a couple of facts. One fact that I'm sure you're aware of is that the sum of the angles of a triangle are equal to 180. So we're going to use that as a fact to help us. Maybe we have two angles and we need a third. We're going to use that. Some other facts that we're going to kind of use as a basis for our discussion are the, properties or axioms where we use in geometry usually to prove that we have two triangles that are equal or congruent. And congruent means that all the sides and all the angles are equal. Okay, and so I think three of these are those, right? We could do angle, side, angle, side, and no, not side, side, side. Okay. Maybe not side, side, angle either. I'm trying to remember. Either way, these two, if we're given this type of information, so if I'm given an angle, a side in between, and another angle, or if I'm given two sides and an angle, I can use the law of sines to help me solve the rest of the triangle. Find the remaining angles and sides. If I'm given side, an angle, and a side, or if I'm given three sides, then I can use the law of cosines, which we're going to talk about in another video, to solve the triangle, to solve for all the remaining pieces. All right, well today in this video, we're just going to talk about the law of sines. And the law of sines says that I can take a ratio of the sine of the angle and the side opposite that angle, and the ratio for each side and angle pair that are opposite each other in the triangle, that ratio is equal for all the sides. So we can actually write this in two different ways because we can sort of manipulate it however we like. So you can put the sides on the top and the sine of the angle on the bottom, or you can put the sine of the angle on the top and the side length on the bottom. I usually use this one, but both of them work just as well. All right, so let's try an example of that. So this is a question from your book. It just says solve the triangle. All that means is find everything that's missing here, right? So notice I have angle B, I have angle C, and I have the side length opposite angle A, which would be side length little a, right? So this guy. Okay, so I want to find everything else. So I think maybe the first thing we need to do for a problem like this, we can't really use the law of sines until we have a pair where I have the value of the angle and I have the length of the side opposite. I need at least one pair and then one other item, whether it be angle or side, to use this, right? Because I have to have three of the four. Let's say I'm just using this first two fraction equality. I need to have three of the four variables so I can solve for the fourth. All right, but we can use the fact that we already know two of these angles to come up with the third, right? So if I wanted to solve for angle A, I can use the fact that, I'm just going to use A, okay, A plus 29 degrees plus 52 degrees equals 180 degrees. This chapter is going to be calculator heavy, so I'm going to be using my calculator. So this is 81. And then if I subtract 81, that's going to leave me with 99 degrees for A. Okay. there are 6 things in this triangle, right? 3 angles and 3 sides. And I was given 3 of them, so I need to find 3 more. So I've gotten 1 of the missing parts. Okay, whoops, let me leave this in, because now we're going to need to use the law of sines. So now I have angle A, and I have the side opposite. So I can do the sine of A over A. I'll just go ahead and use B for right now, since that comes next. I have the angle B, I just need to find the side length B. So I'm going to use the law of sines to do that. So I've got the sine of 99 over 43 is equal to the sine of 52 over side length B. Okay, so if I multiply both sides by B, that's going to bring the B up here. And then I can multiply by 43 and divide by sine of 99. I'm going to do all of that at once. I hope you're okay with that. So once I multiply by B on this side, I don't have anything underneath, or you could put it over 1 if you like. Then I'm basically going to multiply by the reciprocal of this. So the 43 is going to be on top now, and the sine of 99 is going to be on the bottom. I'm going to put that into my calculator. And that's going to give me, oh, wait a minute, we do have to make sure we're in degree mode, because I'm using degrees. So let me show you that real quick. So I'm going to hit mode. Notice I wasn't in degrees. I got a negative answer. That kind of clued me in. So I'm going to move over to degree and hit enter. And then I could hit quit. If I hit mode again, notice degree is highlighted now. Okay, so let's try that again. So I'm going to put in the sine of 52 times 43. And then I'm going to divide that by the sine of 99. That's going to give me 34.306. Notice everything here has 2 significant digits, so I'm going to round it to just 34. I'm going to try and stay on top of that in these problems if I can. And we're using centimeters, so 34 centimeters for side B. All right, the last side is side C. So let's do the same thing for that. I'm just going to keep this same fraction. So we'll have the sine of 99 is equal to, now I'm going to use angle C, so the sine of 29 degrees over C. The math is really the same, so I'm going to multiply this C over to the other side. And then to move this fraction over, I'm going to be multiplying by the reciprocal. Okay, so let's do that. So that gives me 21.1, but again, I'm just going to use 2 significant digits, so I'm going to round that to 21 centimeters. Okay, so this is how we can use the law of sines to solve for different pieces of the triangle. I have a couple of these. Let's try another one. All right, so let's see, I'm given, here's my triangle, right? I don't know if you can see that, A, B, and C. So angle A is 35.3 degrees, angle B 52.8 degrees, and then this is actually side B, which is 675. So I already have an angle and a side opposite, so I can go straight to the law of sines if I want. Since I do have two angles here as well, let's go ahead and find angle C first. So 35.3 plus 52.8 plus C equals 180. So if I add those together, I get 88.1. Now I'm going to subtract 180. And that's going to give me 91.9 degrees. Notice all the results in this problem are done with 3 significant digits, so that's going to keep consistent with that. Okay, why don't we try to find side A next? We could label these if we want. So we'll use the law of sines. We already have angle B. So we'll do the sine of angle B, which is 52.8 degrees, over the 675. So if we're going to try and find side A, we'll use angle A. So the sine of 35.3 degrees over side A. We're going to multiply this side by A. And then we're going to move everything we have here. So pretend you had an A here, right? To move this, we'd have to multiply by 675. And to move this, we'd have to divide by the sine of 52.8. So let's put that into our calculator. That's going to give us 489.69. Just like before, we've got 3 significant digits. So we're going to round this to 490. And this one is in feet. So 490 feet. All right, last one. Let's find side C. We've got I'm going to keep using angle B. So the sine of 52.8 degrees over 675 is equal to the sine of angle C, which we already found to be 91.9 degrees, over the length of side C, which we don't know. This is a little c. Okay, so we're going to multiply it over. And then we're going to move all this over. So we're going to multiply by 675 on both sides, and we're going to divide by the sine of 52.8. That's going to give us 846.95. Again, we're going for 3 significant digits. So we're going to round this to 847 feet. this is starting to give you a good feel for how the law of sines works and what it means to solve a triangle, right? To find all those remaining pieces. There's one more idea in this chapter, and that is there's a formula to find the area of the triangle as well. So just like the others, we can kind of write it with different variables. It looks like we need two sides and then the angle. Let's look at this triangle just to make sure. We need side B, which would be this, and side C. Okay, so it is the angle in between the two sides. So we have two sides and then the angle in between, or we could swap it out. Two sides and then this would be the angle in between and so forth. Okay, so that's what we have here, right? We're going to use this one because this is the information we have, right? We have side B, which is 32.67 inches, and we have side C, which is 52.89 inches, and then we have, So we're really just going to plug into that formula. So let's do that real quick before my laptop runs out of batteries. So we're plugging all that information into that formula, and let's put that into our calculator. I'm going to do 0.5 for 1/2. That's going to give us 722.9, and we're doing 4 significant digits, so we're going to round it to that. And this is an area, which is a square, or 2-dimensional. So we'll have inches squared as our units. All right, well, good luck with trying out this law of sines. I hope you can get a few practice problems in to try it out for yourself. We'll see you in the next video.